Welcome to today's tech tip titled How to Manage In-Process Workpieces Using Associative Integrated CADCAM. My name is Derek Hart. I'll be your moderator today. With us today is Mike Menino from our pre-sales group. He'll be doing the demonstration. And the central issue we're trying to address is one where we have a component that's manufactured in several separate operations, stations in a cell or on different machines, potentially being roughed out before heat treatment, that sort of thing. So a component going through several stages of manufacturing, several manufacturing operations, all of which have a requirement for part definition, for documentations and drawings, etc. This image then represents the several stages of the component manufacturing, each individual manufacturing operation represented here by its own part model, potentially its own drawings, its own fixtures possibly. Starting with, at the top left there, the engineering model of record. This is the part delivered to the manufacturing engineer by the design department, by the designers, and the manufacturing engineer wants to use this as a basis, but certainly doesn't want to change it. Any updates to the manufacturing models will come via updates in this engineering model of record. In the case that Mike will go through here as an example, the engineering model of record carries with it some unilateral dimensions which really need to be updated so that the CAM ready model will be modeled at the dimensional mean, so that there's some tolerance left and right for manufacturing. But in any case, the updates from the engineering model of record to the CAM ready model represent things that the manufacturing engineer requires to do his job properly. So with a CAM ready model, we can use that again as something we won't touch from here. It stays as our CAM ready model, and we can make then associative copies from there and run backwards through the manufacturing process, do the last operation. In this case, that horizontal hole in the back wall is made with this last operation. Additionally, make associative copies from here that represent the machining result from the second operation. This is the second side, almost complete. The first side only half complete, all the way down to the initial material. And as we make these steps from one to the other, each is associative to the one before, and basically they are just simply defeatured using the synchronous modeling tools that make this very easy to do. Now, in addition to these components all being associative to each other, fixtures for specific operation steps can also be associatively developed using the part or specific faces of that part as the starting point for the template development. So this represents all of the manufacturing steps, the manufacturing operations for this component. Each one of these steps then is its own model, its own in-process workpiece that can be documented, drawings can be made, etc. So this is the demonstration that Mike will take us through. Alright, Mike, it's up to you.
Thank you, Derek. Today's NX Tech Tip, we'd like to show how we create the in-process workpiece from start of manufacturing process all the way through to the end of the manufacturing process. Here we have the engineering model of record open in front of us, and engineers tend to design their parts at the maximum or minimum material condition. If we go ahead and start snapping through some of the views here, you'll see that we have PMI on our part here. That's product manufacturing information. Rather than using blueprint, we like to work in a paperless environment where we can actually put the dimensions right on the model itself. And you see we have a series of unilateral tolerances that are all over the part. We don't need to see this anymore, so we'll close out here and go right into our manufacturing session. Here we have a manufacturing engineering assembly. We want to be able to have all our manufacturing steps associated back to the master model, the engineering model of record. This way, if the engineering model of record changes, our in-process workpieces will change, our fixturing will change, and our CAM programs will also update. And here you see I've built the entire assembly for CAM purposes. What I've gone ahead and done was to make it easier to explain and easier to see. I've gone ahead and created an explosion view of how all this goes together. So you see here we have the original engineering model of record, the roller housing that's assembled into our CAM assembly, and from there we must create all the in-process workpieces that are associated back to that. So what we do is we use a tool called Wavelinker, whereas the first thing I'm going to do is create a new part file within the context of the assembly, and I'm going to call this CAM Ready. This CAM Ready model is going to be the one where I take all the unilateral tolerances and add or subtract material to it to make my part right down the mean, and by using Wavelinker. So the first thing I would do is go ahead and create a new part, go into Wavelinker and tell it from this body, Wavelink it into this part file, which is going to give me a associative solid copy of the engineering model. And in here, I used synchronous technology and or any other modeling technique I can to put that part file right down the mean. And then if we go into drafting, you can show now that all our unilateral tolerances have been changed to bilateral tolerances. Let's go back into our assembly. We double click the parent to make it my workpiece. So from there, now we start from the bottom up. I create a part file for my last operation in the context of the assembly. That would be my operation 30. And I Wavelink CAM Ready into operation 30. This now becomes the last operation in the sequence, which is really the same as my CAM Ready in-process workpiece, but we're going to treat the CAM Ready in-process workpiece the same way as if it was our manufacturing engineering model of record, and we don't touch that at all. So from there, we go ahead and create operation 020, Wavelink operation 30 into that, and start removing features and backing off features using synchronous technology or any other modeling capabilities to make it look like it should look exactly in that operation. And the same thing, we create operation 10, we Wavelink operation 20 into it, and then we back out all the features that we don't want to machine. Then we create the blank, we Wavelink operation 10 into it, and we back out all the features that we don't want to see. We also can create our fixturing. By using Wavelinker, I Wavelink the faces off the operation 020, and I start building my fixturing from that so that my fixture is associated back to what they look like at operation 020. And the same thing for operation 030. And that's how we build our CAM assembly. Okay. From here, we can create manufacturing assemblies for each operation where we take the individual in-process workpieces and load them in. Have that already here. So you see here in the first operation we have the blank and the operation 010 assembled in. Go ahead and turn the blank off for now. Go to manufacturing. We have a program that makes the part. This level, I'm going to say toolpath verify. And we're going to do some collision checking. Slow it down. Go right into simulation, where we can collision check against the individual components. and do verification on our part. Stop that here. Once we're satisfied, we're done with the manufacturing. I'm going to switch now back into my manufacturing engineering assembly. Now, the first time we ran this part file, we ran into a series of problems that we didn't foresee at the layout stage. On the back side of this operation 020, the large holes that go through, the drill put too much pressure on the part and we bulged out the back side when it created those two holes. Also, the bearing bores, because of all the heat generated in this operation, they change size as the part cooled down. So we have to separate those into its own operation. And if you look at the locating holes for the fixturing, they are symmetrical. The first time we ran the job, the operator loaded one part backwards, so we ended up scrapping out a part. So we don't want to do that again. So we have to move one of the pinhole locations to make it non-symmetrical, so it can only be loaded into the fixture one way. So the first thing I want to do is create my operation 025 now and start building that. So I'm going to go into my assemblies, say create a new component. I'm going to call this roller. Operation 025. I'm not going to select anything. And we always start from the last operation into the next operation. I'm going to go ahead and make my 025 my current part file. And I want to go ahead now and Wavelink from operation 030 into 025. Now I'm going to make this my display part. And because it inherits the color from its parent, I'm just going to go ahead and edit the color of the part quickly so I can see the difference in the part files just by visualization. Okay. So now we need to go ahead and delete some faces, slot faces. I'm going to go ahead and pick the hole in the bottom of the counter bore using synchronous technology, and we get rid of that in one shot. That's now gone. So this is what the part is going to look like now in operation 025. I'm going to go ahead and edit my exploded view now so we could show you that. That part. Go ahead and drag it out now. So there's our operation 025 we just created. Now I have to go into operation 020 and change where it came from. Originally it came from operation 030. Now we want to change that to come from operation 025 and make the necessary edits. So I'm going to go into 02. We're simply going to double click operation 020. Come into the history tree. I'm going to tell it to edit that link body. And now I want to select it from here. It's telling me that there are some faces that are not associated with where it's coming from now. And that's because those holes weren't there this time. So now I'm just going to go ahead and delete that. So now operation 025 is a separate entity. I can come in here. Okay. Let's go ahead and use synchronous technology now. Make it ready for, so we're going to go ahead and say offset region on the bearing bores. Great. We're going to make them 25 thousandths stock. I'm going to put 25,000 stock on the floors. So that operation is now fixed. And now I need to rough the bores out in operation 010. I make that my work part by double clicking it. Go into the tree. I go ahead and remove the edit that took out the holes. Let's go ahead and, we don't want to go that deep, so we're going to go ahead and pull those up a ½ inch. And we want to leave some stock on there also, so we'll pull them in 25 thousandths per side. So operation 010 is now fixed. Last thing we need to do is move the pin location hole in the master model. I'm just going to go ahead and make that my workpiece. And if you look at the history tree, there's a lot of features that went into this part. I may not be the person who created this model, or maybe some time since I've actually looked at the model, so I don't remember how I actually put in those holes. So rather than go ahead and editing the features, I'm just going to come up to my synchronous technology, and I say move face. I want to move that face in that direction. Let's say a ¼ inch, so they're not symmetrical anymore. Apply that. The hole has now moved a ¼ inch. And if you look in all my in-process workpieces, all those holes have also moved a ¼ inch. Double click my fixturing to once just to make them active. Those pin holes, those pins have now moved a ¼ inch. If I go back into my manufacturing, we now see that the two rough bore diameters are there and that the pinhole has moved in the first operation. All I have to do is simply come up here and regenerate. So we face off the part. And since I am using workpiece, it does see that those two bores are there and it does mill them out. I don't have to go ahead and change my cutter path. Finish mill. We drill now in the new location. The part is complete. And that completes this session.
Good job, Mike. Another very informative tech tip. I'm sure many of us are already thinking about how to develop these separate models for each manufacturing step, each manufacturing operation. Thanks again.